You might have heard this viral, spicy claim floating around the internet. Does infinity actually equal negative 1/12? Welcome to this explainer. Today we're unpacking the context and the actual truth behind one of the most infamous, heavily debated mathematical mysteries out there. We're going to look at exactly where it comes from, why it makes people so incredibly mad, and how it, quite literally, secretly holds the fabric of our universe together. Let's get right into it.
So here's that spicy claim you've probably seen. 1 plus 2 plus 3 plus 4, going on literally forever, somehow adds up to a negative fraction, negative 1/12. I mean, no way, right? Well, let's dive in and separate the clickbait from the rigorous mathematical truth. Because to truly understand what's correct here, we actually have to completely rewire how we think about the very symbols we use to do math.
Section 1. The spicy math misconception and why it diverges to infinity.
Notice the stark contrast here. If we look through the everyday lens of basic classical arithmetic, like on the left side there, adding larger and larger positive numbers obviously just creates a sum that grows completely without bound, right? It diverges to infinity. The sequence of partial sums just straight up fails to converge to a finite limit, period. But, and here's where it gets wild, look at the right side. Advanced mathematical contexts deliberately assign it this smoothed value of negative 1/12. So, while classical methods fail to give us a finite answer for a series that's blasting off to infinity, advanced physics and complex analysis absolutely require this smoothed value to function.
Section 2. Ramanujan's Ingenious Heuristics, a mathematical shortcut.
To figure out how anyone arrived at this totally bizarre negative fraction in the first place, we actually have to crack open the notebooks of the brilliant, self-taught Indian mathematician Srinivasa Ramanujan. He essentially used a really clever algebraic shortcut. By taking the original series, multiplying the whole thing by 4, and then subtracting it from itself, he created a much simpler alternating series, 1 minus 2 plus 3 minus 4, and so on. Now, using classical methods from the 18th century, that alternating series is assigned a value of 1/4. So you end up with negative 3c equals 1/4. You divide both sides by negative 3, and boom, you hit negative 1/12.
Section 3. The magic of analytic continuity, smoothing out infinity.
Now, to be fair, Ramanujan's heuristic of just manipulating infinite series like their regular finite sums, that's technically flawed by classical grade school rules. You can't just insert zeros or shift divergent series around willy-nilly. But his incredible intuition pointed directly to a rigorous truth found in a branch of math called complex analysis. So the absolute crucial point to understand here is that analytic continuation is kind of like extending a mathematical map. Where the original boundaries of an equation throw up their hands and say diverges to infinity, this extended map allows us to bypass that singularity completely and assign it a specific finite value.
And this whole map extension thing relies heavily on the famous Riemann zeta function. Basically, this function sums the reciprocals of integers to a power we'll call s. It's pretty straightforward. When s is greater than 1, everything behaves normally. But, and here's the kicker, if s is less than or equal to 1, the standard math completely falls apart and diverges.
And this brilliantly illustrates exactly how the rules change. See, by extending that zeta function to the negative integers using analytic continuation, specifically by setting s to negative 1, we actually flip those fractions upside down. That gives us our original series, 1 plus 2 plus 3. But because we're using that analytically continued map we talked about, it bypasses the divergence entirely. It magically calculates that constant sort of center of gravity smoothed value of negative 1/12. It matches Ramanujan's wild, out-of-the-box intuition perfectly.
Section 4. Real physics, vacuums, and strings.
Now, if you're sitting there thinking this is just abstract mathematical witchcraft, it's really not. This exact calculation literally builds the foundational fabric of quantum mechanics. Take 1948, for example. Physicist Hendrik Casimir discovered something absolutely fascinating. If you put two uncharged metal plates extremely close together in a perfect vacuum, they still experience a physical force. Why? Well, because a vacuum isn't actually empty. It is absolutely boiling with virtual photons and standing energy waves. When you sum up the infinite virtual energy waves bouncing between those plates, you get our exact divergent series. By using Zeta regularization to extract that smoothed negative 1/12 result, physicists perfectly predicted a real, measurable, attractive force that pulls the plates together. And honestly, the coolest part? That negative sign mathematically proves the force is attractive.
And if you want something even more mind-bending, this is the exact same math that holds string theory together. When physicists compute the energy levels of infinite harmonic string oscillations, they have to sum up all the harmonics. And guess what? That results in our exact divergent sum, which evaluates, again, to -1/12. That specific tiny fraction becomes the absolute mathematical cornerstone that requires bosonic string theory to operate in exactly 26 spacetime dimensions. Without -1/12, the mathematics of the universe's most fundamental building blocks completely falls apart.
Section 5. Redefining the equal sign and the meaning of the word sum.
To comfortably accept that adding up whole numbers somehow governs string theory dimensions through a negative fraction, we really need to look back at Leonhard Euler's pioneering philosophies all the way from 1760. Euler famously realized that treating divergent series with our traditional grade school definition of addition just creates artificial limitations. He argued that to move science forward, we shouldn't think of a sum as simply adding numbers up one by one until you stop. Instead, we have to assign a series the value of the analytical formula that actually produced it.
Ultimately, this whole viral meme kind of tricks us, right? It presents a specialized, highly advanced concept, but it uses the familiar symbols of grade school arithmetic to do it. Writing out 1 + 2 + 3 = -1/12 is intentionally provocative. In the context of regularization and analytic continuation, that equal sign really shouldn't be read as adds up to. It really just means is mathematically associated with. Yes, the series is fundamentally divergent in classical math, absolutely, but its underlying generated structure holds the value of -1/12.
So, now that we've unlocked exactly how this misconception works and seen how an impossible sum fundamentally shapes the quantum world rather than breaking it, we really have to wonder. If infinity can be mathematically smoothed out into a tiny negative fraction to calculate the very forces of the quantum vacuum, what other impossible rules is our universe hiding right in plain sight?